Hello, everyone, and welcome to this session on e-bike design with MODSIM approach on 3D Experience platform. I'm Shri Krishna S. Chittur, who is going to be hosting this session along with my counterparts Ramesh Lakshmipati and Roberto Guizar. And today we are going to use this opportunity to share some exciting um, aspects of MODSIM approach using this e-bike design. Before we get started, we want to run a quick poll by you. It should not take more than a few seconds. Let's go ahead and take the first poll. It should be opened up on your screen, and I'm already seeing the responses. So we'll give it a few more seconds. While everybody's voting, maybe I can quickly share my background. So I come from aerospace industry and with a background in computational fluid dynamics. Then I moved into the SOLIDWORKS reseller channel. I used to work for a reseller in North America, and 6 years ago, I moved to Simulia as a part of the product management team, and was responsible for go-to-market and product management of fluid solution on the platform. But since last 2 years, I've been primarily leading enablement activities related to all simulation domains as a part of the 3D Experience Works portfolio. So I'm quite excited to share this e-bike story with you as it brings together all the aspects, all the values of leveraging MODSIM approach. So in today's presentation, we're going to start off by introducing to you what is 3D Experience Works portfolio, and then we'll dive straight into the MODSIM journey that involved design of this e-bike and improvement and enhancements associated with the same, and we'll wrap up with a few key takeaways. 3D Experience Works brings the power and breadth of 3D Experience platform to SolidWorks users. You are already quite entrenched with the awesome capabilities of SolidWorks in your design process. However, the 3D Experience platform integrates all brands and all products of Dassault systems and brings their value with a native and fully integrated solution from design to simulation to manufacturing and governance and marketing and sales. However, in today's session, we're going to focus on synergy of SolidWorks and the Simulia-based applications on the 3D Experience platform. Some of the key values that 3D Experience Works bring to the table is it leverages the fully integrated atmosphere of 3D Experience platform, where a SolidWorks CAD user can continue using the SolidWorks desktop, but take advantage of integrated simulation solutions on the 3D Experience platform. Yes, we understand that SolidWorks also offers a desktop simulation solution. However, the Simulia-based simulation roles on the 3D Experience platform brings some of the advanced capabilities, providing you value up or a step up from SolidWorks desktop. Next is the user experience, which tends to be designer-centric with guided user experience that walks novice users step by step across the setup process in order to accelerate product innovation. The capabilities offered on the platform are quite comprehensive from a simulation standpoint. We leverage Abacus-based technology for structural simulations, CST-based technology for electromagnetic simulations, SIMPO, which is the same technology that powers SolidWorks Plastics, but we have an equivalent of the same on the platform. And then we've developed new fluids capabilities on the platform for fluid flow and thermal simulations. Cloud is a major value offered to the SolidWorks users, where they can run quite expensive computational simulations, but leveraging cloud for storing the data as well as executing simulations while reducing IT costs in terms of hardware and software and people. The solution offered on the platform is quite scalable across roles, product complexity, and development stages, from paper sketch design all the way to production. Last but certainly not least, the most important value offered by simulation capabilities within the 3D Experience Works portfolio is the collaboration values, which allows the users to quite seamlessly collaborate across the product development chain and also across the supply chain. And hence, 3D Experience Works offers simulation-driven design in a collaborative cloud environment. What does this mean in a real product development atmosphere? That's why we have the e-bike example. And let me take you through this exciting MODSIM journey. So in this case, we decided to build an electric bike as an example. Obviously, this is a fictitious case. However, we put ourselves in the shoes of our customers and went through the journey of designing a product. So some of the key drivers for us in terms of developing a e-bike, it was the growing popularity of electric bikes for catering to sharper rise in the demand for urban mobility, or more specifically green urban mobility. A lot of tech savvy consumers who are open to trying new technologies. So to address this market need, we introduced to you the City Shark. This is the electric bike that consists of a battery pack, an electric motor, and a vehicle frame that is purpose built for commute with an electric powered motor. Now let's switch gears and talk about MODSIM approach. MODSIM, in very simple terms, leverages synergy of modeling, in your case, in case of SolidWorks, and simulation, which in our case leverages the platform values. And it can be broadly classified into 5 categories. The MODSIM journey starts from capturing requirements. So in this case, the key requirements includes lighter frame from a structural standpoint, lighter motor pack from the electromagnetic motor supplier, extended battery range, which is a request from the battery supplier, and compliance readiness. These requirements can actually be captured on the 3D Experience platform and tied to the product tree so that you can trace specific dimensions, features of all these products all the way up to the requirements. You can ensure that the simulation results are allowing you to meet these requirements, and most importantly, change management of the same. Another class of MODSIM that we're going to talk about today is the collaboration. In this case, we had multiple people across the globe, and we had a manufacturer followed by a couple of suppliers. These are people who are working from different parts of the globe. And in fact, this project was done during COVID. So there's no physical interaction between any of the stakeholders during this project. Leveraging the collaboration capability and also project planning and project management capability is quite key to class 4 of MODSIM. Class 1, which is the heart of MODSIM. And you may have already seen some of this with the SolidWorks CAD and simulation desktop portfolio. So here we leverage tight integration between SolidWorks for CAD or modeling and 3D Experience for simulation roles. And together we do a lot of design exploration to ensure that each of the subsystem meets the target criteria, meets the target requirements. From crash compliance to strength and durability to motor performance, battery thermal management, manufacturability from an injection molded plastic standpoint, and readiness for electromagnetics compliance. So we've talked about what is MODSIM approach, and now let's see the MODSIM journey in action. So we're going to start all the way from requirements. In case of the e-bike, the key requirement from a structural standpoint is to have a lighter but stronger frame that is safe, quick, and extremely reliable for commuting on city streets. From a battery standpoint, this is also the we could almost say it's the food or the energy house of the bike. The goal here is to deliver maximum power for the targeted range while ensuring safety from a thermal standpoint, both the safety of the battery and also the safety of the rider during the urban commute. The requirement from the electric motor supplier is to have a lighter, quieter, and more efficient motor. What does that mean? That means we need to maximize the torque while minimizing some of the torque ripple effects that has a direct impact on smoothness or harshness of acceleration and reduce noise while achieving the targeted efficiency. And then compliance. In this case, leveraging simulation, we will try to gain confidence in whether the product in its integrated format is ready for compliance. So from a requirements standpoint, 3D Experience Works allows you to efficiently capture the requirements and manage them throughout the product innovation cycle. And all these requirements will actually be tied to the product tree. Next is the collaboration. We have the design work that's done on the 3D Experience platform and simulation work that's done, the design work that's done on SolidWorks and the simulation work that's done on 3D Experience platform, and they're very tightly integrated with each other, breaking the silos in a multidisciplinary environment. So here, we're not exporting or importing files. We are staying in the same model data while we're adding more and more simulation information throughout. While SolidWorks brings very powerful on-premise desktop capability, 3D Experience complements the same with a cloud-based solution that makes your life easier for running expensive simulation types. So in very simple terms, the integration between SolidWorks and simulation on the 3D Experience platform allows quite streamlined product development process, efficient MODSIM workflow, and powerful what-if scenarios. So let's look at it from the lens or from the eyes of a mechanical designer. The goal here is to explore design alternatives in order to meet engineering requirements. So during the next few minutes, we will talk about how durability or life of the frame and the strength of the frame was ensured, how the injection molding simulations were performed to choose the design of the battery casing, how thermal simulations were performed to ensure the thermal safety of the rider as well as the battery, and last but not the least, electromagnetic simulation of the motor to ensure higher efficiency and lower torque ripple. So from a collaboration standpoint, 3D Experience Works with the MODSIM journey offers seamless interoperability and concurrent modeling and simulation. So let's go ahead and dive straight into it. We start our journey from the desktop and then go up to cloud. With 3D Experience platform, you can directly launch your SolidWorks environment with Design with SolidWorks app. So here is the UI that walks you through the installation process of the SolidWorks, which you're already familiar with. Once SolidWorks is installed on the platform, you can request access to the collaborative designer role for the SolidWorks. And once you have access to this role, you're pretty much set with launching your 3D Experience UI directly from the cloud. And you see the compass that connects the powerful 3D Experience platform capability to your SolidWorks desktop. So here we are going to ensure this digital continuity because the CAD is created only once, and that's within your SolidWorks environment. And then you save it on the platform with no need to import or export CAD files. And then you can come back to SolidWorks as many times, make as many design changes, and update your simulation model. Most importantly, we are going to leverage the multidisciplinary environment of 3D Experience platform from a simulation standpoint to assess the product performance. So in here, we're going to launch our SolidWorks UI and load up the current version of the e-bike model. And now we want to make various changes from the structure of the frame to the battery casing design to the electric motor. As you can see on the right hand side, I have the compass, and that allows me to save this model originally created in SolidWorks on the platform and launch the structural simulation capability that's powered by Simulia Abacus technology directly from the SolidWorks UI. So now we are in the 3D Experience platform user experience, and we're going to go through the structural simulation of this e-bike. With that said, what you saw is clear digital continuity that allows you easy and instant access to latest version of the software because it's cloud-based, so you get very quick updates. And the cloud installation is quite seamless. You can get started within an hour from the minute you have the license up and running. So now we've built the foundations. We've captured the requirements. We have established the collaboration between the OEM and the suppliers and the key stakeholders. We've installed 3D Experience platform and connected the same to SolidWorks. We've even loaded our SolidWorks model on the 3D Experience platform. Now we're going to go through the simulation journey in terms of strength and durability, electromagnetics performance, thermal management, and manufacturability. For strength and durability, you can take advantage of durability and mechanics engineer role that brings industry-leading Abacus solver for performing comprehensive structural simulations covering statics, implicit and explicit dynamics, fatigue analysis to assess the overall structural integrity of the product. It also comes with automated modeling and meshing capability that significantly reduces the turnaround time for product development and simulation. It also comes with advanced material modeling capabilities, which add a huge value when you're early in your product design exploration phase. With that said, we first start with the assessment of structural integrity of the frame in terms of, is the material light enough? Is the structure strong enough to sustain various load cases? So this simulation involves a linear static stress analysis followed by a durability analysis. The von Mises stresses indicate higher stresses near the neck of the frame, whereas the durability analysis indicates lower log of life or lower lifespan near the joint that's quite closer to where the electric motor is mounted, where the back elements come and connect with the central part of the frame. Based on this information, we could redesign in SolidWorks, come back to the platform, and update the simulation data. What about electromagnetics performance? So electromagnetics engineer role offers industry-leading CST solver technology in the context of 3D Experience platform, and offers a broad solver choices for applications ranging from antennas to motors to PCBs in terms of assessing and optimizing the electromagnetic performance. Here is the permanent magnet electric motor that's used in the design, and our supplier is also using SolidWorks CAD, but is exploring various designs and ranking them based on maximum torque value. So several CST simulations were performed in order to ensure that there is highest torque, reasonable efficiency, and acceptable level of torque ripple. Torque ripple is a key performance indicator that ensures smoothness in acceleration for any electric motor. So leveraging performance trade-off study, you can assess the electromagnetic performance between various designs within the electric motors within the 3D Experience platform. Can also ensure that the results are yielding higher yet smooth ramp up of acceleration while minimizing the noise experienced by the rider. Then we switch gears, talk about thermal management. In case of battery thermal management, we use or we leverage fluid dynamics engineer role, which enables designers and engineers to perform fluid flow and thermal simulations in order to explore and improve the product designs. The fluid dynamics engineer role brings a very guided user interface that is quite tailored for non-simulation experts and experts alike. It offers automated meshing with boundary layer modeling technology, comes with industry standard turbulence models and advanced wall modeling options. It has quite comprehensive fluid flow and thermal physics capability. So in this case, we are primarily interested in exploring whether a casing needs to be plain or whether adding long slots would help in meeting the thermal requirements. So again, we start with the SolidWorks environment. We save this model on the 3D Experience platform. So in order to extend the range, we've gone up from 3 battery modules to 4 modules. And what you're seeing on the right-hand side, maybe I can take a step back. What you're seeing on the right-hand side is the guided user interface offered by Fluid Dynamics Engineer role that literally walks users through every step of the simulation setup process, providing real-time feedbacks and guiding them on the next steps. So here, we are first applying materials and defining the fluid region, which is inside the battery pack. And you can see a stack of 4 modules. And what we are looking at is the surface temperatures of all the cells within the battery pack, as well as the surface temperature of the casing. The goal here is to ensure that all these temperatures are below 35 degrees C. And it looks like, in this case, both the casing and casing with slots have very similar thermal profile. Yes, the casing with slots has relatively lower temperature for some of the cell surfaces, but they both meet the key criteria. So based on this decision, we now would pass the buck to the plastic designers. We also look at very intuitive 3D results to ensure that not only the history or the numerical data makes sense, but also the field information or the contour plots are telling the same story. So as you can look at the cross section of the battery pack between the 2 models, both of them look very similar in terms of their temperature profile. So since both of them meet the criteria, we now move on or leave the design decision to the plastic part designer, who's going to design and analyze the injection molding simulation with and without the slots. That's using the plastic injection engineer role that allows users to validate and optimize injection molded part designs quite early in the product development process. This has a very nice designer-centric guided user interface, kind of similar to the fluid dynamics engineer role. And it's the same technology that exists in SolidWorks plastics, except this is on the 3D Experience platform. It leverages quite extensive plastic material library. As of today, we have more than 4,500 materials from various plastic manufacturers across the globe. the plastic part designers or mold designers or even mechanical designers who design plastic parts can ensure the manufacturability of or answer questions such as, is this part ideal for injection molding? Are there going to be weld lines? Are there going to be air traps? Are there going to be knit lines? These type of questions can be answered by performing filling simulation, packing simulation, cooling and ejection simulation. And the best part is leveraging the multi-physics attribute of 3D Experience platform. You can even perform verbiage analysis leveraging Abacus solver that exists on the platform under the hood of a structural role. So in here, as you can see, we have a really nice material library that users can access through a material palette. You apply the material library, define the injection location. There's option for users to either manually specify the location where molten plastic is injected from the mold into the cavity, or there's option for automatic computation of these injection locations to get you started. So in this case, we placed 3 injection locations based on experience. And what you are going to see on the left-hand side is the filling simulation inside the cavity with the casing that is plain. And on the right-hand side, you're going to see the same simulation for casing with slots. There are 2 factors to be considered, which is how fast is the filling and how complete is the filling. So in this case, what we noticed is that the casing that is plain is actually much cheaper to manufacture, and it does meet the criteria as opposed to casing with slots, which takes a relatively longer time to fill because of the slots. Now that the battery supplier and the motor supplier have finalized their designs, they pass it back to the OEM. And now comes the part of compliance. In terms of compliance, simulation can help you gain some early insights on whether this product as a whole in its integrated view is ready for compliance. This is not a compliance simulation, but this is a simulation to check or to ensure or to get an idea of whether the product is ready to pass the compliance. Using the structural mechanics engineer role, we are going to perform a crash analysis on various use cases or load cases, which could be the bike crashing into a wall. And it's actually quite important in terms of the impact this is going to have on the structure and the motor and the battery. The last thing you want is for the battery pack to blow up as a result of a massive impact to a structure. Right? So here we're going to take advantage of the Abacus solver technology within the structural mechanics engineer role. And Abacus, I don't know if many of you have heard, Abacus is actually the leading industry solver when it comes to explicit dynamic scenarios. This could involve drop tests, impact tests, really massive crash simulations. So these are kind of the areas where Abacus has been known for in the industry, especially in the automotive industry for decades. And another set of key capabilities this role offers includes comprehensive material modeling and robust contact modeling capabilities. So here, what you see is the bike in it with all the components integrated. And what we are going to see is the effect of the impact or the crash on the structure, on the rim, and so on. So with intuitive post-processing, you can get a sense of how each component is behaving during the crash. You can see the tire coming off of the rim, off of the wheel during this simulation as well. So this gives a sense whether it's the design itself is ready to go through a compliance. A simple reason being compliance tests, the physical compliance tests are quite expensive in nature, and you want to reduce the iterations, both in terms of time and cost. Next is the electromagnetic compliance readiness. Again, using the electromagnetics engineer role, which also brings in very powerful capabilities to assess signal integrity, power integrity, and electromagnetics compatibility. So here, the antenna of this e-bike is placed on the handle. Um, this is a GPS antenna we are talking about, which helps to locate the location of the bicycle itself. And in order to pass the compliance, and this is quite mandatory for anyone using electronic components, you need to ensure that the electromagnetics emissions are within the limits. So we ran simulations in a fully integrated environment and assessed and made sure that the electromagnetic emissions are not going to affect the rider, and it passed the the required guidelines in terms of the electromagnetic flow field around. So you can see the red area indicating higher electromagnetic activity or emissions near the handle, where the antenna is placed, but not so much in the rest of the system. So now we look back at the requirements. So we have a lighter frame, an extended battery, a lighter, quieter, and efficient motor, and quite compliant or compliance ready design that gives a lot more confidence in going through the compliance process. With the e-bike MODSIM journey, as you could see, we're able to deliver end-to-end modeling, simulation, and design exploration with a strong integration between SolidWorks and 3D Experience platform. So let's talk about some of the key takeaways of the MODSIM approach. From an engineering standpoint, MODSIM approach with 3D Experience Works portfolio offers digital continuity from requirements to product delivery, simulation-driven design exploration where you're making design changes in SolidWorks and then you're updating the simulation model automatically on the 3D Experience platform. Very tight integration between multiple disciplines, as you could see. After the plastic simulation, we can also perform warpage analysis using the structural solver on the platform. Seamless collaboration across supply chain, in this case that involved the battery manufacturer, the motor manufacturer, and the OEM that's making the bikes. High performance cloud computing was used in all the simulations, so that allows to accelerate the turnaround time of the simulation driven design process. What does this mean from a business standpoint? On the business side, first and foremost, it helps you get really first in the market. It's faster time to market, offer an innovative product portfolio within a shorter turnaround time. That helps you beat the competition. And a great example here is I don't know if you've paid attention to how the launch events of Apple has evolved over last many years. When the second or third version of iPhone came in, they used to have one event every year and launch one iPhone. Now they have multiple events, and even if there's a single event per year, they launch multiple variants of iPhone, multiple variants of iPad, and watches and so on. However, being able to manage those variants and deliver them in the shorter turnaround time, that's very challenging with siloed tools for different aspects of product development. That's not the case with the MODSIM approach, because everything is tightly integrated and you can have multiple variants within the targeted timeline. You can reduce prototyping, compliance, and warranty costs, which is a huge part of product development from a business standpoint. And obviously enhance operational efficiency, leveraging the collaborative aspects. And last but not the least, reduce IT hardware and software costs, which can be or can get quite expensive as you start using simulation to drive the product development process. With that said, I'm going to wrap up my presentation, and now we can open up for questions. Before we do that, I would like to introduce my colleague Ramesh, who's going to run the next poll.
Excellent presentation, Shri Krishna. So thanks for showcasing the whole MODSIM approach with the e-bike story, right? So that is really some really powerful insights into not just what the 3D experience platform is, but all of the tools, like a lot of these tools that are all connected, and so it really showcases a very powerful way of being able to work in a collaborative environment, where there are multiple key stakeholders involved, and all of them are now working with a connected set of tools, starting with SolidWorks. So here is my, I'm going to launch the second poll. So based on the presentation that you saw from Shri Krishna Chitur, so this is the second poll question, which is a very simple: did you see any value in any of the solutions that has been shown today, or in general, like the 3D experience platform and all of the MODSIM tools that Shri Krishna discussed with us? So we'll just give it a few seconds for everybody to respond. See, we have about a 30% vote in, so we'll just give it a few more seconds. Okay, it's very interesting response. I don't know if you can see it, Shri Krishna, but about half of our audience want to learn more about the tools, and about 25% of them are actually, it's pretty interesting to see they already have the tools and are using them. So that's really good to note here.
Yep.
All right, so I think the responses are holding steady. So thank you for thanks to the audience for for voting in your responses. I'm just going to go ahead and close the poll, and we can open it up for questions. So again, there is a Q&A box as part of your GoToWebinar panel where you can type in your questions. So I was actually sending a couple of chat messages. I hope you guys saw it in the in the audience. But yeah, now is the time for Q&A. We do have some time to take on some questions based on what you saw today. So let's just give it a few minutes for. Actually, there is one question about. Are there any plans to integrate additive manufacturing analysis? That's a good question.
So additive manufacturing capabilities are already available on the 3D experience platform, but not all of them are exposed to the 3D experience works portfolio, specifically for SolidWorks users yet, but there's definitely plans to make them accessible for SolidWorks users. So the short answer is yes, we already have those capabilities. It's just a matter of time, in which we will expose these capabilities.
Yeah, and then we'll also share a link so you can see all the AM processes that which we can be simulated, like to study the thermal and residual stresses, for example. If you want to get more information, we'll send you like a web link where you can learn more about exactly what types of modules are available for AM simulation. Good question. Great answer, Shri Krishna. So, well, the second one is not really a question. It's just email. Can an email of the copy of the presentation be shared with the audience?
So I believe the recording is going to be shared with the audience. I'm not sure if the slides themselves will be shared. So as soon as the webinar is complete, probably in the next 1 or 2 days, you should get a notification on the recording.
That's correct. Yeah. So give us a couple of days.
Yeah, and if you have any of your colleagues who might be interested, they can still register and watch the recording, um, even in case they have missed the session.
That's a good point. I mean, you can always share these recordings. That will be sent to you. Just give us a couple of days. We'll process everything, put the recording in place, and you'll get an email from GoToWebinar with the recording link, and which you can review at your own pace and time, as well as you can also share this with your teammates and other key stakeholders that you think might benefit from watching this presentation. So another question that just came in, Sri Krishna, is what license do you need to access 3D Experience and the simulation tools?
That's a very good question. So the simulation portfolio on the 3D Experience platform is organized by roles. A role represents a user persona, right? So we have close to 10 different simulation roles on the platform, for structures, electromagnetics, and fluids. For fluids, electromagnetics, and plastics, and even motion, we have one role, so it's quite easy to understand that. For structures, we have a varied set of roles depending on the requirements. We have the entry level role called structural designer, and all the way up to structural performance engineer, structural mechanics engineer role for performing advanced simulations. So, in a sense, we need to understand your simulation requirement in order to recommend a role that fits your requirement. And all these roles have a prerequisite that will automatically get you access. And then there's a license that allows you to connect platform to SolidWorks. It's called collaborative SolidWorks collaborative role, right, Ramesh?
Yeah, it's called Design with SolidWorks app. So it's but collaborative designer for SolidWorks role. That's what the name of the role is. But in essence, it's like, you're talking about a user license, right? So you can install these roles on multiple machines and use them on multiple machines, but the role is going to be actually a named user license type of.
Yeah. So in very simple terms, you need one license for connecting SolidWorks to 3D Experience platform, and specific licenses associated with your simulation requirements, depending on whether it's structures, fluids, plastics, EMAG, or all of them.
So another question that came in, actually we're starting to get in a lot of questions, which is great. Thanks everybody in the audience. So the one question is, so we have already invested in computer licenses, both SolidWorks and simulation. Is it possible to convert a few to take advantage of 3D Experience and cloud-based software? How much of the capabilities is already available to us? So that's more, that's a great question, but it's more of I would say, please get in touch with your local SolidWorks reseller regarding, to get more information about how exactly you can do that. So it's more of a sales question rather than a technical question. So I would defer you to please contact your local SolidWorks reseller to get more information regarding this. Anything you would like to add?
Yes. So, in terms of your SolidWorks environment, you can either continue using the desktop product, which is fine, but now there's also equivalent versions that are available on the platform. There's 3D Experience SolidWorks roles, where you can move completely to cloud from your desktop solution. So as Ramesh said, your best bet is to reach out to your reseller. And usually for SolidWorks simulation customers who are looking to step up their simulation capabilities, there's always some sort of promotions going on. So, please, as Ramesh said, reach out to your reseller to explore opportunities.
Perfect. Thanks, Shri Krishna. I think this that also leads into the next question. I think you might already given that answer. So the question is, I have SOLIDWORKS Premium. Can I access these tools? So like I think it's like you said, it's you can continue with your SOLIDWORKS desktop tools, and it's and then if you want to get access to the platform, it's more of a natural extension to what you already have. What are the limitations of the simulation module? That's an interesting question.
Yeah, I mean, is there a particular domain that you're referring to in terms of structures, fluids, or EMAG? Because the value that the simulation roles on the platform bring to the table is they're actually addressing some of the gaps or limitations of SolidWorks simulation desktop portfolio, or rather providing a step up, right? So, and usually when we talk about limitations or gaps, we need to be quite specific in the context of a use case, right? For example, whenever we talk to a customer, it probably doesn't make sense for us to compare our feature matrix with the feature matrix from another competition. What we are interested in is understanding your use case, your application, and whether we have those capabilities or not. And 99% of the scenario we will, given Deso has a pretty significant presence in the simulation market. So it really depends on the use case for us to understand if there are any limitations in place. But in general, 3D Experience Works portfolio was introduced to complement SolidWorks portfolio and provide a step up or value up.
Yep. Perfect. So one last question, and we'll wrap it up. Shri Krishna, is can any of the simulation tools be accessed via a hobbyist license? I guess the person is referring to a more of an evaluation license type of scenario.
Well, there's two pieces to it. So if you have academic email, for example, if you're a student or if you're a research coming from academia, there is a edu or academia portfolio that is provided to universities at an extremely lower cost. This is mainly to encourage research and activities within an academic setting. For example, if you're a student who's doing a project, either in undergrad or grad school, you can really take advantage of our academia portfolio by talking to your professors and whoever manages licenses in your university. However, that's not meant for commercial usage, and there would be a lot of restrictions on that sense. So if you're referring to that's one avenue, if you're in the academic circle. If not, the alternative is what Ramesh was suggesting. We do offer term licenses from 3 months to 6 months to a year and so on. So whatever fits the bill.
Right. Yeah. And I think, like you rightly mentioned about academia, like I believe it's called 3D Experience Works Engineer package that contains, both the CAD, the PLM, and also the simulation tools on the 3D Experience platform for a very affordable price. Okay, I think that's all the questions we have, Shri Krishna. So thanks once again for an awesome presentation, great learning. Hope the audience got a lot of value out of your presentation, and so thank you again for being presented today. So with that, I know let's wrap it up, and I wish all of you a good rest of your day. Stay safe, and we'll see you next time.